Alan is the CEO of Opturion, a spin-off of Monash University and Data61. Opturion has developed a unique optimization technology based on artificial intelligence and is active in supply chain, transportation, logistics, manufacturing, and healthcare. Alan has a bachelor's degree in mathematics from the University College of London and a master's of scientific technology and control systems from Sheffield University. He has applied advanced technology to a wide range of industries, including manufacturing, energy, financial services, supply chain, transport, health, and human services in the UK, USA, Japan, and here in Australia. Alan has written and presented papers on process control, optimization, information management, AI, and digital disruption. He's a fellow of the Institution of Chemical Engineers and a graduate of the Australian Institute of Directors.
Okay, we're a spin-out from what used to be called CSIRO. It's now called Data61 and Monash University. Our main claim to fame is we're the only commercial provider of what I call 21st century technology, and it's really a decision support system using the technologies from AI. So it's very different to what anybody else would give you, say, based on math program or linear programming. So we use AI techniques to solve these complex problems. So just worth backing up on what we mean by decision support. It's when you've got a complex problem, lots of choice and change. Of course, we don't have that in supply chain, do we? Basically, you can't figure out what to do next. Too many options, it's too complicated, and you often don't have time. So this is the sort of thing that we work with our customers to provide. Things like routing, scheduling, warehouse management, all that sort of stuff are complex problems. And the optimization landscape has changed. When I was first starting off, you talk to a decision support person and they talk about cost, cost, cost. But nowadays, it's much more about compliance. Like if you've not got a compliance solution, it's useless. And you also need to maintain customer service, and then you start worrying about cost, not the other way around. And it's actually the way people do it, too. They would not look at a low-cost solution which was not providing their customers with the service that they were promised. But we call it decision support. It's not really automation because at the moment, people still want to stay in control. They want to give it a little bit of a tweak. That will change, but that's quite common at the moment. People like to think they can change it to suit themselves. And it works at three levels. So you've got the strategic level, which is, okay, I want to acquire some assets, I want to enter into a contract. What parameters should I be considering? You've got the tactical, what we call the allocation problem, which is I've got some resources, how do I best use them? And then you've got the operational, which is something's changed, I need to react quickly on the day or very quickly during the day. And these are the levels that people are interested in. And these are some of the people that we're working with. So to say that companies are using AI, probably true. All different sorts of companies. Some companies are nowhere near it. Other companies are quite deeply into it. So it's like the future is here, but it's been unevenly distributed argument. And you'll find that more and more of this will happen. So I just thought we brought you back to a definition because there's loads of definitions about AI. I'm very much thinking about the decision-making AI, not the image recognition, voice recognition, that sort of thing. There's a whole raft of stuff. And as the previous speaker said, the human being's very good at doing lots of things. We're focusing very much on, I've got a complex decision to make. How do I make the best decision given the information I've got? Which is a fair part of management, to be quite honest. And I always show this because it gets a laugh. This is the Gartner hype cycle. Now, AI, thankfully, has come out the other side. It went up the peak, down the bottom, and now it's come out the other side. So I would say that it's now a productive technology. There's still a lot of inflated claims on what it can and can't do. But I would say from a point of view of practicality, there's certainly for decision-making, AI has come of age, probably in the last 5 years or so. I mean, this is what you're faced with. When it comes to making decisions in supply chain is worse than manufacturing because it contains manufacturing, and it's worse than transport because it contains transport. You know, the only other area I think that's worse, and that's made by humans, is health. You know, you think supply chain's complicated, forget it, right? But stay in supply chain is my advice. don't go into the health service. So you've basically got the sorts of problems that people are pretty good at sorting out. But the problem is you never know whether they've actually made a very good job of it, because by the time they've done it, things have moved on. And that's one of the key issues. It's very hard to audit. Did my team do the right thing? And they don't actually like being audited either. So having something like AI gives you some advantages. And this, I like this diagram. It's not mine. I stole it off the internet. But I think that's pretty good, because these are actually the sorts of areas where AI can make a difference. Like, what the hell's going on? What does that mean? What's going to happen? And then what do I need to do? It's not that difficult. And we do this as managers all the time. You know, we figure out what's going on, often with incomplete information, conflicting information, and then we say, okay, we're going to do this. Because we have to make a decision. We can't not make a decision, and we don't always have all the information. And I think this is the sort of area where I think AI can make a difference in these complex processing, complex decision-making situations. Now, I'm really pleased that someone mentioned back office automation, because I haven't got time to tell the story, but this is the big area that no one really looks at. We get these poor guys who are on minimum wage, and we grind the hell out of them, and yet the guys sitting in the office clipping pieces of paper together and ringing up complaining about mistakes we've made, or complaining about mistakes others made, or apologising for mistakes, we don't look at them. And they're a growing band. It's even worse in the public sector, where there's more and more managers on less and less doers. And because we get rid of the doers, we make more mistakes. So we need more managers to deal with the mistakes. And I think this is a big area where AI can help, because it's not simple business rules. There's a little bit of complexity there, but maybe not that much that it needs an absolute rocket science application, just a bit more. So I think if we can get more compliance, make less mistakes, we need less back office people to deal with the mistakes. If we can provide the right level of customer service consistently, without fail, we won't need so many people, and the rest of the jobs that the people are doing in the back office, we can automate some of them anyway. So it's a triple whammy. And I think it's not. I'm glad the previous speaker mentioned that, because I've thought this for a while, and this is where the higher margins will come from. We've beaten the hell out of the trucks, we've beaten the hell out of the drivers, we've beaten the hell out of the warehouse staff, but we haven't dealt with that other issue. So I was going to go through a few case studies. I'm glad I've got through that quickly, because these are more interesting stuff. The sorts of AI we do are really around the decision-making and the forecasting. So you can use AI techniques for decision-making and forecasting. There's lots of others, you know, so-called predictive analytics. There's lots of different applications, but we've done forecasting. So this is one of the projects that we did for RACV, which is sort of supply chain. Basically, roadside assist is a function of, say, the season, day of the week, whether it's a public holiday, whether it's a hot day, whether it's a cold day. And the thing with roadside assist is there's a very, very fine line between having too many vehicles, and that means your costs blow out, and not enough vehicles, which means your customer service goes down. There's a very fine line between them, and you've got to really decide the day before, the week before, how many people do I need to deploy in my roadside assist. So we developed a forecasting algorithm which takes in all this data, and it works at two levels. On a sort of seasonal day of the week level, it can create a forecast for the full year. But then you can modify it based on, well, were we busier last week than we expected, or were we less busy than we expected? Then you can modify it so the day ahead or the week ahead forecast is different. And you can get about 95% accurate with this is not Watson, this is fairly basic AI, right? You probably don't need Watson for this sort of thing. And so imagine if you're running a business and you can predict to within about 5% what your workforce is required in a very changing environment, then you've got a much better chance of reducing your costs or controlling your costs, and also delivering the customer service rather than having a complete guess. And we see this in supply chain all the time. Has anyone heard of the beer game? Yeah? That's the problem, right? They don't tell me until the last minute, and I pile resources on, and all of a sudden I don't have enough to do, and then I pile them back on, and I take them off. And this happens all with retail and everything. So you'll find that, for example, in a retail supply chain, the warehouse might have predicted or given a prediction, and by the time they get to Saturday night, they got many more cartons than they thought, and they have to work a Sunday, and then the retailer gets upset, and it's a sort of vicious circle of, because you don't forecast and predict and man up, and it burns money because, you know, you bring somebody on, there's nothing for them to do, then it's gone. You can't sort of store their work up for the next day. So this is another one where we worked with a company called SCLAA that I'd actually never heard of, but they're the guys who make bubble wrap. So you've heard of them now. But they also make meat and cheese packaging. And the problem there was they have a production process which is quite complicated, but one of the parts that's most interesting is the printing part. And the reason that's interesting is because whenever you're printing plastic, you've got a multicolour press, but you can't fill it up with all the colours you'd ever need, so you have to change colours. Changing colours is messy, time-consuming, and it's a problem. So what you see there is you've got, say, if you're going through printing 4 different bags, you've got, in that particular case, you've got to go from red to yellow back to red, and from green to blue, and back to black, and so on and so on. So you imagine 2 weeks' worth of 275 production jobs. It's very complicated. So what we did with them was we worked out a way to reorder the jobs to minimize the setup time. And that's the size of the problem. And that's about 10 to the power 100. They tried linear programming and it gave up after two or three jobs. We managed to do a whole 2 weeks' worth using AI. And the reason is that the AI is very clever because it says, cuts away the problems, basically cuts away the problems which are not practical. So you might have a million choices, if only 20 of them are actually practical. They could actually make the product. Then it focuses in on those products and that says, okay, let's try and find a cheaper and cheaper one. That's in essence how it works. It's totally different to mathematical programming, which goes away for 2 hours and says, okay, until I've finished, I can't tell you anything. Within a few seconds, we can tell you something which is practical. And if you leave it running for another few minutes, it will get cheaper and cheaper and cheaper. So it's a totally different approach. And if you can see there, before, in a fortnight, we were using 7,000 minutes of setup. Afterwards, we were using 3,500. So that's reduced the setup time by 50%. So on this particular machine, it was 30% more productive. And before you say, I don't believe it, the GM at SCLAA called America and said, I've got this great new algorithm. And the guy said, right, we'll stop working weekends as of now. He said, well, we haven't bought it yet. Well, you better buy it, haven't you? So they basically stopped working weekends because the machine became much more productive, which in Victoria on penalty rates is a big deal for a manufacturer. So these sorts of things, so if you've got an advanced manufacturing process or anything that's got significant setup times, even things like transport and logistics where you've got to unhitch and hitch up trailers, you can minimize that, you make more use of your fleet. This is one we did for the UK, which is Wincanton, which is a big delivery. And this again is an example of a very large, multi-day, complicated decision support problem where you're doing the national distribution for a lot of different customers. So the issue there is I can't actually get to where I want in one go necessarily. So how do I stage the deliveries through the various DCs I've got? And this is quite a big problem. You know, like 13,000 pallets were being shipped to 1,000 consignments a day. And the fleet's quite large. So we had a fleet of about 300 trucks, 300 prime movers. And this is the sort of problem that, again, linear programming finds very difficult to do because there's too many choices. It just falls over or takes hours. And this is an example of a lot of the so-called more strategic optimizations where you're looking at a big picture optimization or big picture decision support, where you're saying, okay, yeah, everything's on the table. What can I do? So those are the sorts of problems that we've been solving for transport companies. So what can AI do in supply chain, in my humble experience? More consistency, more compliance, well, guaranteed compliance, consistent, correct customer service. That will get rid of 99% of a lot of people's problems because there's no more opinion, no more bargaining. You know. And the second thing is, as part of that, you eliminate errors. So that means you can reduce your costs significantly because you don't have to pay people to fix them or to point them out. And I also agree with the previous speaker, things like invoice reconciliation is a no-brainer, right? Three-way reconciliations for invoices, you shouldn't be employing people to do that nowadays.